Everybody, welcome back to another fun and exciting pre-calculus class. Today we are going to be starting chapter number 2. Chapter number 1 was just really quick, just 3 lessons, real quick review, and we're just going to dive right into it, into trigonometry today. We're on page number 10, lesson number 2.1. Let's go ahead and show this on the screen. And in this lesson, we're going to be talking about the different trig functions. You might remember from a couple lessons ago when we were talking about trigonomic functions that there were only 3 trigonometric functions. Well, in this lesson, if you're looking at table A, you're going to see additional trigonometric ratios or more trig functions. So let's go ahead and talk through it and talk about exactly what the book is trying to tell us here. All right, so a few words. We need to make sure we know some vocabulary for this chapter. The first word that's there in bold is the word function. Function are equations or mathematical representations, whatever you want to say, that will yield exactly one outcome. All right, so we've dealt with this before, like in Algebra 2, but it's something that has an input variable and an output variable. Let's do something very simple. So we'll do let's see, y equals 3x. And in this case, y is the output variable, or y is going to be the solution, and x is going to be the input variable. What do I mean by that? If I say on any given day in a factory, they make X amount of the product that they're making. I don't know what they're making, but they could be making anything. T-shirts. Let's say it's a t-shirt factory. So they make X number. Well, that can vary based on the day. And so this is the input. This is what's going into the equation. And let's say that they have 3 factories. Well, the 3 is a multiplier, and it's always going to be 3 factories unless one of them is shut down or something like that. But so all 3 factories make the same amount. And let's say that the factory makes, I'll keep it simple. The factory makes 10 t-shirts. That would be a really bad factory. But let's just say that they make 10 t-shirts. Well, how would we do this? We would put the input in here. And so now we'd say y equals 3 times 10. Y equals 30, excuse me. Y equals 30. So our output, our solution is going to be 30. Notice we got one solution. That's it. Only one. What does that mean? Well, that means that this is a function. Functions only give you one solution. What if we got, let's back this up and let's say that y squared equals this, okay? So now we're here, y squared, and this is y squared. Well, in order to solve this one, we would have to square root y squared, and we would get y equals plus minus the square root of 30. We'd have to simplify that out. I'm not going to simplify it right now. But notice that we got 2 answers on this one. So this would not be a function. Why not? Because I got 2 outputs. Okay, I put in one input, I put in 10, but it gave me 2 outputs. That's what a function is. And maybe that's just a little bit of review for you. We're not going to be too worried about that right now. We will get into that deeper as we continue on. But let's go back to this. The dependent variable, it depends on what? It depends on the input, depends on what you put in. So the dependent output is called the solution, okay, the dependent variable. The independent variable is the output, okay? It's the input. What does that mean? It is what you put into it. It's the data. For example, it's the fact that I told you that they made 10 t-shirts. That's the data that I gave you. That's the input that goes into the equation. And then the output is the answer that you get from solving it. And some of that is right there in the book. I went a little bit more in-depth in my explanation than the book does, but I want you to kind of understand that. Now, for right triangles, there is only one possible fractional value for each ratio. You can only get, for sine, there's only one value for sine, and that's for each angle. So for each right triangle, there's only one possible value for sine. There's only one possible value for cosine. There's only one for tangent of each angle. Now you could look at the different angles. So the trigonometric functions are sine, cosine, and tangent. That's what we talked about in the last chapter. But now, when we go back to the book, if you look over at the book, you're going to see there's additional ones. What does that mean that there's additional ones? Well, each one of these functions has what's called a reciprocal function. If you remember what a reciprocal is, a reciprocal of a number occurs by swapping the numerator and the denominator of a fraction. Remember this from Algebra 1 and Algebra 2. If I have 2 over 3, okay, the reciprocal of 2 over 3, we did this when we multiplied fractions together, right? So divided fractions. So if we had this as our, let's say we had 1/3 divided by 2/3. Remember, we had to flip this fraction over. Well, that is what we're doing. We're doing the reciprocal. We're flipping the fraction over. So what's the reciprocal of 2/3? Flip it over and we get 3 over 2. Okay, the numerator becomes the denominator, and the denominator becomes the numerator. Notice what happens when we multiply. Remember, when multiplied together, reciprocals always equal 1. So let's go ahead and multiply this and see what we get. 2 times 3, well, we could do it a couple different ways. We could cancel this if we want, or we can just multiply it, which is fine too. 2 times 3 is 6. 3 times 2 is also 6. 6 over 6 equals 1. Reciprocals always equal 1. Always, always, always. Okay? And so when you flip them over, you're going to get 1. Now, because of that, let me show you another one. Let me show you one with letters. If we're doing sine, we have the trigonometric function for sine is opposite over hypotenuse, right? Let's flip sine and let's see what we get. So now we have hypotenuse over opposite. Remember, I said if you multiply them together, you always get 1. Let's see if this is true. OH over, really that should be OH again because we'll just write it the same way. So notice cancel, cancel. What happens when they both cancel? You get a 1 and a 1. You get 1 over 1 or you get 1. So even the letters cancel out to 1. So whenever you do this, you're always going to get 1. So in other words, this is called, and you can look there in your book, this is a true statement. And it's true all the time. It never changes. So if you look down here, statements of equality that are true for any variable are called identities. This is an identity. The reciprocal identity means that you always get 1. You're always going to get 1. That is a statement of truth for no matter what. Letters, numbers, combination of letters and numbers. When you flip those fractions and you multiply, you get 1. Well, because of that, we have trigonometric ratios. We have extra trigonometric ratios. And let me show you what they are. So for sine, we have opposite over hypotenuse. And the reciprocal value for sine, or when you flip sine, so basically you get h over o, hypotenuse over opposite, that is called cosecant. CSC is the way that you abbreviate that, CSC. You may notice on your calculator you do not have a CSC button. Most calculators. Now, if you got a really fancy calculator, maybe you've got it. Most calculators will not have a CSC button. Why not? Because you have a sine button, okay? And you can just invert sine. In other words, if you look at table B, what you can do is you could say the sine of A is going to equal what? In cosecant, it's the flipped of sine of A. What is the flipped of sine of A? 1 over sine of A. Okay, so the cosecant equals this. Because what is the sine of A? Let me go back to this right here. It's this, right? So sine of A over 1, when we flip it, we get 1 over sine of A. So what does this equal? That equals the cosecant. So you can just, on your calculator, you can just put 1 over the sine of A, and it's the same thing as cosecant. So you don't really need a cosecant button because we just divide it 1 over the sine gives us the cosecant. Okay, and we'll get used to that. We'll do that, and you'll be like, oh yeah, I understand that. It's not a problem. For right now, you need to understand the concept. What's the concept? The concept is that cosecant is the inverse, the flip of sine. That's the important part. Next, we have the cosine, and the cosine was the adjacent over the hypotenuse. The inverse of that one is called secant, S-E-C, secant. And that one goes hypotenuse over adjacent. Again, we're just flipping this. A over H, flip it H over A. And then the third one is the tangent. And the tangent was the opposite over adjacent. So again, just keeping in line with that, the flip of that, the inverse of that is called cotangent, C-O-T. And cotangent's interesting. Tangent's an interesting one because you might be saying, well, why isn't sine and cosine? If it's tangent and cotangent, why is cosine not the inverse of sine? Well, there's a reason for that. And again, that's something we're going to get to. So if you're already thinking that way, that's good. That means that you're already kind of looking forward to what's coming. And we'll talk through that. We'll explain why that is and why that isn't the case for sine and cosine. So cotangent is going to give you A over O. A over O. So adjacent over opposite. Very important that you understand the what's happening here, and they're flipping, and very important that you memorize table A and B. I put here reciprocal identities are shown in table B. They are foundational. Okay, what does that mean? You gotta have them. And they must be memorized. I don't do this very often in math class. I don't have students memorize very much in math class, very little, okay? This is one of the things, though, that you must memorize. You have to know this. And notice right here, I said, you will thank me later, and you will. You'll come back and you'll say, oh, Mr. Steve, thank you so much for telling me to memorize those, because now I know how to do trigonometric equations. Now I know how to do all these other things that I need to in trigonometry. Okay? All right, let's go ahead and really quickly here, I don't want to spend too much more time, but let's do one of these. Let's go to the next page, and let me show this to you here real quick. Let's try example 1. So again, I'm not going to spend a lot of time here because I feel like with the explanation that I just gave you, it should be pretty basic. So if we look here, let's look at what's going on. The example 1, find the values, the 6 trigonometric values. So that means that they want you to find sine, cosine, and tangent, and they want you to find cosecant, secant, and cotangent. So what I'd like to do is I just start with sine. It typically comes first in the the order of the explanation from the book and on your calculator. So let's start with sine. What is the sine of this triangle right here? Notice we're looking at reference angle A because it says it right here. We're looking at A. So let's look at A. What's the sine for A? Well, what is sine? Sine is opposite over hypotenuse. 6 is the opposite. Hypotenuse is 10, 6 over 10. But notice they reduced 6 over 10. You always have to reduce 6 over 10. Whenever you can reduce a function, you reduce the function. And they got 3 over 5. Now, very easily, they just moved over and did cosecant. What is cosecant? It's just flipping your 3 over 5. Now it's 5 over 3. Because remember, cosecant is the inverse, or it's the reciprocal. I don't want to say inverse because that's not right. So it's the reciprocal of sine. So just flip it over, and then you're going to get cosecant. Okay. Now we go to the cosine of A, which is now 8 over 10. So again, you reduce that, you get 4 over 5. Flip it for the secant, you get 5 over 4. Tangent is 6 over 8, which reduces to 3 over 4. And then you flip it 4 over 3. There you go. The next example, they want it in decimals rather than doing the fraction. So they just ask for it in decimal. Use the calculator. So what you're doing is you are, well, first thing you had to do here is you had to find the missing side. The C is the missing side, so they used Pythagorean theorem right here. And they found the missing side. The missing side was square root of 221. And so then everywhere, so this would be C, this would be your hypotenuse, equals the square root of 221. So everywhere that you see a C in your trigonometric functions, you would put square root of 221. And then they actually want you to divide it using your calculator. So you would say 14 divided by square root of 221, and that equals 0.9417. So there's your trigonometric function. Notice that it says right here, to avoid calculation errors, do not round answers until the end of the problem. This is helpful to store calculator values in the calculator memory. Maybe you know how to use that on your calculator, maybe you don't. If you don't, use your owner's manual. You can always look it up online, look up the PDF online, and you can find out how to store numbers. But it is very important in Trig not to round off, because you end up with numbers that don't quite match up at the end. The last one here is basically doing the same thing. Now we're using a 30, 60, 90 triangle. You remember that? I told you about those special triangles, and I said those are in the front of your book. If you look back on page, it's just the inside cover of your book. You will find those. Let me get to that real quick. I think I got it right here. Yeah, there we go. See, special triangles. Here's the precalculus formulas, and notice that you know your special triangles. The 30, 60, 90. That is 2x. That's the hypotenuse. The shorter leg is x, and the longer leg is x square root of 3. Okay, and so when we have that information, we don't even need to use the Pythagorean theorem on this one. Why not? Because we know what all of these things equal. Notice it says do not use a calculator. So we don't need to use a calculator. Why not? Because we can plug it into the 30, 60, 90 formula, and we can come up with all of the from there we can come up with all of the different trigonometric functions. Okay? Notice that they do want them. So there's two different things here. Sometimes they want them in what's called exact, okay? And sometimes they want them in decimal. The decimals are not exact. They're rounded off. These ones, I think I called it bacon the other day. You got to put the little equals, but not in equals. It's kind of like with a little squiggly line. Those are approximate values. And with these ones are exact values. Why are they exact? Because we kept the square root sign, because we kept the fraction, we did not divide them out on our calculators. All right, so that is what they're looking for. If you missed anything there, you can always rewind that again, watch it again, and hopefully that helps you out. All right, that's all I got for you. See you later. Bye-bye.